And when the dirty air goes through this block, the contaminants will be consumed by the bacteria, then come out with treated air. The treated air is odorless and is clean. And it can be exhausted either directly from here, or you can pipe it to our stack, which is the configuration in this plant.
Can I ask you a question, please?
Yes, please.
When you treat it, it goes through your exhaust and it's incinerated, so to speak, or burnt. Are there any entrapments of acid mist in the biofilter?
Very, very little. Very, very little, because your air speed is not that high. But we never measured the mist. But I think it's very, very little, because the reason for that is we add fresh water to the top, right? We add fresh water to the top. You're not recirculating the acidic water. You add fresh water to the top. The water is just the one through thing. It's added in and it goes down and exhausted. It's discharged. So your air, if it's carry any mist, is not going to be that acidic. But I don't have data to show you what the pH is going to be.
So the porosity in the media helps greatly until it gets plugged and filed after about 5 to 10 years.
That's a very slow procedure. Yeah. Eventually it will be. Yeah. All right. That is for the air part. Then for the water part is this. You got a water supply from here. In this design for this plant, you use potable water. Then we add water to the system from two locations. One is we call that lower irrigation, which is in between the two different media layers. This adds a lot of water to this because we want to wash out the byproduct sulfuric acid from this line. Basically, most of the sulfate will be washed out from there. We also have an upper irrigation, which is a spray nozzle type of thing. We add water to the top, plus we have nutrient mixed into that spray. Here's the nutrient tank. The nutrient will be stored in the tank with a small nutrient pump. Add the nutrient into this water stream and add into the top. This way you supply nutrient to the whole body of the media. All the water supply, lower and upper, is controlled by timers in the control panel. So we will cover that part later. That timer will control how much water you add into the system, how often you add it. Okay, this is a kind of more vivid view of your biofilters. Again, in the lower section is the inlet air, plenum, air getting in here, and then from that we have we call that media support system, and the media is pretty heavy. If you look at here, you have two layers of media, different kind of media. The lower media layer is we call that the scorifill, which is a lava rock type of media, which is inorganic. And it's very acid resistant. You can stay there for, we have some filters run more than 10 years, so that's no problem. So we are guaranteed the media life of 10 years. I don't see any problem for this thing to degrade. And here is the middle irrigation layer in here. And we have another layer of media called the organic media, which is on the top of this. The good thing for the organic media is some sulfur bacteria, like I said, the methylmercaptan, the dimethyl sulfide degraders, like the organic media better. So we put the organic media on the top to attract those bacteria to grow on the top section. So the good thing for this is you develop a pH profile inside of this. So this is our unique design. Your lower section of the bed have very low pH, and when the gas move up, the media pH will increase a little bit because most of the hydrogen sulfide is already degraded in the lower section. So that makes sense. And in the upper section, you have a higher pH, which is suitable for other bugs to grow in there. So then if you look at the pH profile, you have lower pH in the lower section, higher pH on the upper section. If you take bacteria sample from different locations, do analysis, you will see different groups, species living in different locations. Just do the job as a whole family. Okay, here is the specific design conditions for this biofilter system. The flow is 25,000 CFM. We designed the relative humidity is 65%. We really have a few measures to bring the humidity up to 100%. So as I talk, we have a humidification chamber. We also have 2 layers of irrigation in the filter. And the temperature 55 to 100 degree. The feed hydrogen sulfide concentration between 5 to 20 ppm. Reduced sulfur other than hydrogen sulfide is 2.5 to 5 ppm. And the ammonia concentration 0.2 to 0.5. And the inlet odor is 90,100 to 18,000 D to T. I explained this a little bit in the morning session. Probably not everybody familiar with this kind of stuff. D to T means dilution to threshold. When you take an odor, the measurement of how strong the odor is, this is the indication. They just talk to okay, how strong the odor is. The European people call that an odor unit. How many odor unit? In this country, everybody talking about D to T. That means if I take a sample, air sample from your duct, and I send it to a lab for analysis, that lab has to be certified. We call that an odor panel. Generally, odor panel depends on lab. They probably have 6 or 7 people, certified people. Those people's nose has to be certified. Okay, you cannot be too sensitive. You cannot be numb. You cannot smell anything. Those people are certified nose sitting in there, form a panel. Then they receive your odor sample. Those people don't see the sample. They don't know what is in there. They don't know how strong that is. They have a machine in a different room. They do dilutions. Okay, they make dilutions to your sample. You know, probably first they dilute so many times people can smell. Then the panel people will sit in a different room. Everybody have a small mask close to their nose. They smell. Now, if you smell something, you push a button. If you don't smell, you don't push a different button, whatever. Until 50% of the people say, okay, I smell something. Okay, that is called DT50. Means half of the people smell it. At that point, the people in the other control room said, okay, I diluted the original sample 10,000 times, reach that point. Then your D to T level is 10,000. Okay, that is how they measure how strong the odor is. Okay, that means if your inlet odor is 90,100 to 18,200, we need to reduce your level 90%. Okay, so that's from our system. 90% will be gone after it goes through the biofilter. All right, then in terms of chemical stuff, hydrogen sulfide removal efficiency is 99%. All the other non-hydrogen sulfide stuff is 90%. Okay. And number of bays, we call that bays. People here refer to that as chambers. We have 2 chambers. Okay, chamber 1, chamber 2. I think chamber 1 is the one close to this to that building. Chamber 2 is on the other side, and each chamber is independent. And each chamber we have 7 fiberglass covers to cover it. So then you have media. As I said, you have 2 different kinds of media. The sclerophyll media is in the lower section. You have 8,500 cubic feet. and you have the van fill media top up, and the residence time, that means the gas stay in the biofilter is 45 seconds. 45 seconds. And in addition to the biofilter chambers, we also supplied irrigation and humidification chamber. We supplied equipment and controls, and a media support system, and the nutrient pumps. Here is a PID of this project. There are a little bit too crowded here. I'm sorry about that. Too many information here. Basically, you have seen here is the two chambers. This is chamber number 1. This is chamber number 2. And in this square, it shows the irrigation panel. What we have is what you call the irrigation chamber. It's a stainless steel box, and you have a bunch of solenoid valves and the nutrient pump in here. Those are controlled by another control box. We will get into the basement, and we'll, in a few minutes we'll see it. Okay. We also have a nutrient tank in here, which need to be. It's a 110-gallon tank. The nutrient there need to be replaced roughly about every 4 weeks. Okay. People need to add in a new batch of nutrient to support the bacteria to grow. And outside of the biofilter, you also have a well. It's called a humidification chamber, humidification sump. In that sump, we supplied 2 recirculation pumps. And I think the other contractors supplied the blower, the duct work, and other stuff. Okay, what this does is you have some water recirculated in this sump with this pump. Then the water is added into the humidification chamber here on the top, and the dry air is humidified with this water and go to the biofilter. And this water was collected to the bottom and flow back to this sump. You also have a drain sump. That drain sump collects all the biofilter waste, like the other gentleman's question. You add fresh water to the top, and the water goes through the biofilter and become acidic. This acidic water will not be added back into the system. It will be discharged to the drain tank and back to the system, to your sewer system. Okay, here's the picture of the system. Okay, this is chamber number 1. This is chamber number 2. Those I did not include the blower. The blower is on this side. Then this is the duct. The duct will come out the blower with a 42-inch pipe, then split it into 2 30-inch pipe in here, and get into the humidifier chamber. This is the humidification chamber. Before this white cover, this chamber is the humidification chamber. And those 2 covered with the white covers are the biofilter. And you have the hatches here. You can open and get inside of it. If you need to take a media sample, in any case, if you want, and also do the regular maintenance to change out or check out the spray nozzles conditions, you can walk into it. And
excuse me, you have PPE. Do you have like a little mask on? Or?
Yes, you have to follow the confined space entry, regulations. Yeah, true. And in the outlet of the biofilter is collected to this pipe. You see it here? The air gets in from here, from the bottom, and it goes up and collected to the end duct. The 2 ducts join together to this big duct, and you have a pretty long run. This duct goes to here and go another 2 or 3, floor, and get to the other roof, and eventually this will connect it to your stack. Okay. This is the control stuff, control panel. This is the control panel. This is the irrigation panel. This is the nutrient tank. All these three is the major part you need to look at in a regular basis. This is located in the basement. Okay, a little bit closer look of the control panel. All these pipes are the water pipe to fill up your irrigation sump. Is Jim here? Oh yeah, he was here this morning. I think they designed this. This is not our supply, so I don't have many details on this. But based on him, this is a solenoid, not the valve. It's controlled somewhere, and when the sump water level is low, they have a flow switch in there. So the flow switch will open this solenoid valve to add water, and when the water reaches into a certain level you want, then we'll close this valve. Right? This is our control panel to control the irrigation. We add water to the biofilter. I show you in detail here. If you look at the panel, go back one more. Oh, sorry. If you look at the panel, it's a stainless steel box. You have a power switch. Okay, you have a power switch this to turn the main power on and off. And also when this is on, you have another power switch here. I will show you in detail. You only have six buttons or whatever in here, okay? Now you have, this is the main power switch on and off. You turn this on to supply the power to the control panel. If the power is on, you have an indicating light. This one will be on. Then you have two switches in here. This for the nutrient pump. Okay, each switch is a three-position switch, either by hand. If you turn it on hand, you will force the nutrient pump to pump nutrient to the system. And the off position turns off. And generally, you should set this to the auto position. Let the control panel to control the pump when the pump is supposed to be on and off. Okay, whenever the pump is on, you have an indication light. The P, you see the P101, P102 running light. It shows the pump is on. This is the inside of the control panel. Basically, it's a bunch of relays and fuses. And what we need to generally, if we need to adjust anything, is the setting point of the timers. That means I set the timer how often I need to add the water, or how long I need to let the solenoid valve to stay on. So all this information is in the O&M manual. Okay, if you look at the manual, we already supplied the manual to the engineers. I think the plant should have that. If you refer the manual, you will see the maintenance schedules and the setting of the timers, so on and so forth. Those are the seven timers. Generally, we set that this first timer here, it controls the cycle time. So we set the cycle for 20 minutes. So every 20 minutes, the whole cycle will repeat itself. Okay, every 20 minutes. And each cycle is going on, we add water to the lower irrigation first. Okay, right now the setting is for 30 seconds. Okay, the lower irrigation water will on for 30 seconds. When that is done, then the upper irrigation and the nutrient pump will be on at the same time. Okay, the upper irrigation on for 10 seconds, the nutrient pump will on for 36 seconds. That will add water and nutrient to the top. So these three timers is for chamber 1. And chamber 2 is you get the same settings, use the other three timers. This is for chamber 2, these three timers. So basically, you can work on with is resetting the timers. These timers are already preset according to the design condition right now. The numbers I just set you is the current setting. And if the operation condition changes, you need to reset the timer. Like you think, oh, I had too much water in there. I don't need that. then you can reduce the timer settings from 30 seconds to 20 seconds. Then you reduce 1/3 of the water use. Okay, if you think that will be indicated by your pH. If you take a drain sample, your pH is too low, you think, oh, I need to add a little bit more water. Then you just increase the setting time a little bit longer. So that is very straightforward.
What pH are you looking for?
We're looking for between 1 and 2. The drain pH, drain water pH.
Between 1 and 2?
Yeah. Anything between 1 and 2 is good.